To another video. This is the first weekly update of this channel, and in this video I'm going to be showing off this electronics kit and show some of the basic capabilities and what is achievable with this kit. So here we have our Arduino kit. If I can get a better angle. Yeah, perfect. We have our basic Arduino kit and we have our breadboard here. So I'm going to explain all the components one by one and show what they're capable of. So this is a breadboard, and what this does is it allows you to make circuits without any soldering. Soldering is when you heat up metal and use it to make the connections in a circuit permanent. So this breadboard, if you can see, has a bunch of tiny holes in it. So what these tiny holes allow you to do is each hole is a slot to put something metallic in. So you can connect wires to it, LEDs, whatever you want, buzzers, etc., buttons. You can connect them all into these tiny holes. And how this works is, as you can see, there's two blue lines and two red lines. So what the blue lines do is they're the negative side of the breadboard, and the red lines are the positive, as you can see by their little markers on the side. So there is one central section in the middle between this red and this blue line. There's the central section, as you can see, this entire area. And around the edges, you have these two smaller miniature lines. So in a breadboard, the movement of current is usually limited to from the bottom of this row to the top of this row, or the top of this row to the bottom of this row. So basically, all of these things in a row going downwards, if you can see that, all of these things going downwards in a row or upwards in a row are connected. So if you have, let me get a pen or something so I can show you more effectively. Yeah, okay, I've grabbed a pen. So if you connect something to these lines over here, and then you connect another thing to these lines over here, one space to the left, these two circuits won't be connected because these are isolated. Whereas for these long circuits heading across the board, the current here connects to the current here, the current here connects to the current here. So these circuits go in this direction, and not circuits, these pins go in this direction, and these pins go in this direction. And current cannot cross over from one side to the other across this border. And this allows you to make temporary circuits. Next, we have a few more parts in here. Let's see what I can show you. So this is the Arduino. It's the most important part of this kit. And what it allows you to do is it allows you to do some basic things. It's not extremely complicated, but it allows you to do more advanced methods, etc. with the Arduino. So, for example, these little holes right here and here are power output and input. So these slots can output a voltage. These ones can too. There are some ground cables, which is basically, if you've ever learned about positive and negative in school, then the output is the positive terminal and the ground is the negative. So current flows from positive to negative from the output to the ground. And over here we have analog in. So what this allows you to do is it allows the Arduino to read electric currents. I'm not sure if you can see that. It allows the Arduino to read electric currents, these ones. Then you can power it by two sources. So you have this source is meant for plugging in a 9-volt battery to power the circuit board, and this is for plugging it into your computer. There's also a few additional pins over here for miscellaneous functions, and a red button right there. This red button, if you press it, not sure if you can hear that, but it basically interrupts the circuit and opens it, meaning that current won't flow anymore and this Arduino will switch off. So if you want to reset the Arduino or switch it off for a second, then press this red button here, okay? Next, we have an LCD screen which comes wrapped in this display. In this, not display, this LCD screen comes wrapped in bubble wrap to make sure it doesn't break. And this LCD screen, everything is already soldered for you. And what you need to do is you connect pins to this, and using a program, you can choose what to display on the screen. So this allows you to display small screens for small pieces of text for your projects. And it's a bit complicated to use. Not really, but as a beginner it will be. And once you get the hang of it, you should be able to display whatever text you want. So you can write small messages, you can write like error messages, anything you want to display, etc. Next, we have the expansion shield. So the Arduino may not have enough space to add everything you want. So you can connect this to your Arduino, and you can connect smaller devices onto this. As you can see, it's just like an Arduino. You have, what do you say? These are all ground. Let me get the pen back. These are ground, these 5. These 5 are 5 volt. You have a bunch of digital, and what is this? This is analog. Analog and a mix of 3 volt, 5 volt ground, and VN1. So this circuit, expansion shield allows you to connect more things to your Arduino than you normally would be able to. Next, we have this breadboard. This is a miniature breadboard, just like the one. You can see this doesn't have the horizontal lines, just the vertical ones. And again, current cannot cross over from the top to the bottom or the bottom to the top. On the edge of these breadboards, you'll see these little, can you see that? These little extensions and these little slots. So what this allows you to do is it allows you to connect multiple breadboards together. So this slot feeds into this hole on another breadboard, so you can attach them together and make a bigger one. Next, let me put everything back so that this doesn't become too disorganized. Real quick. Next, we have a resistor card underneath here. So if any of you learned physics in school, you'll know the rule V equals IR. So when the voltage is the same, increasing the resistance decreases the current, and decreasing the resistance increases the current. So that means they're inversely proportional. So what this card allows you to do is it gives you a guide for the colors on a resistor. So depending on the color, you basically add the resistances together to find the total resistance of the circuit. So as you can see, this has a green first band. So you can go to green is 5, and you'll see 100 kilo ohms is the resistance of a green band. Yellow band is the multiplier. So the multiplier will be, or sorry, no, I'm explaining this wrong. But if you want to find a more detailed explanation, you can search online. Sorry for not explaining. But yeah. Following along, we have our stepper motor, which actually comes free with this kit. So what this motor allows you to do is it allows you to make physical changes occur using your Arduino. So you can plug this into your Arduino through a method, through the wire. It actually comes in this small bag. So this is the stepper motor. Apparently this comes free, but as you know, this is always included in the price. They're just saying that to get you to feel a little happier. This is a servo, sorry, not stepper. There's a difference between servo and stepper. They're used for different applications. Servos, I'm pretty sure, have lower torque than stepper motors. And these are little attachments that you can attach so that you can, to the front of the motor, so that you can make them do different things. see what next. Next, we have some small electronic components. So what we have in here is, let me open this real quick if I can. Okay, so what we have here is a photoresistor. So if you can see that, what a photoresistor does is it increases the resistance when sunlight hits it, or light. So this can be useful for applications where you want to detect sunlight and allow an electrical current to pass through when there is sunlight hitting your circuit. Maybe it's useful for automated plant watering systems, maybe anything related to botany, photosynthesis, etc. Next, you have an IR receiver. So there's actually a remote control in the set, and this is the piece that allows your circuit or your device to receive input from the remote so that you can like control it from far away. Next, we have a vibration device. So when you plug this in and supply a current to it, then this should vibrate. In addition, there is one last thing in here. Let me see if I can get it out. It's a flame sensor. So if this touches a flame, it's going to give a signal that you can detect and use it in your projects. So if any of your projects involve small flames, etc., then you can use that. And put all this stuff back. And let's move on to the next compartment. Next, we have a motion sensor, if you can see that. So what this allows you to do is if anything moves in front of it, for example, you move your hand, then it will send out a signal that you can detect. And this is really useful for projects such as automated systems that activate when someone walks into a room, for example, you can detect their motion, or for self-driving cars. If you make a miniature self-driving car, then you can use this to detect its environment. Next, this is a power supply for breadboard. So when you run a circuit, you need a way to give it power. So this allows you to connect a 9-volt battery or a USB and supply power to your circuit. It has a bunch of outputs, and a switch to prevent the flow of electricity. And what this allows you to do is it allows you to supply power to your circuit. Next, we have some various resistors over here. So if you did physics in school, you'll know V equals IR. Increasing the resistance decreases the current, assuming the voltage is the same. And this allows you to reduce the current, which is useful if you're using LEDs, because LEDs at too high of a current can actually burn out and fail. And you don't want to damage your LEDs or destroy them, so you'll need to use resistors. Next, we have some various displays and this little microcontroller, which microcontrollers are a little complicated, so I won't explain that right now. But you have a display. These are individual lights, and these allow you to display numbers. So you will be having a way to display whatever you want. Let's go to the back side. Next, I've organized this in an arbitrary way. You can change it. This is the wire to connect your Arduino to your laptop. So it has a USB plug, if you can see that, and a Arduino cable. So what this allows you to do is it allows you to connect your computer to the Arduino, and allows you to power it and transfer code onto it so that it can perform different functions. Next, we've got different connection wires. So we've got male wires, as you can see, which have a male connector on both sides to be plugged into different things. These come in a package, but you're supposed to separate them, like just pull them apart. But I haven't done that since I haven't used any of these yet. And these are female connectors, so these allow you to connect male ports to each other. Next, you've got the 9-volt battery connector. So remember I showed you the port for connecting a 9-volt battery? This little thing allows you to plug in a 9-volt battery and supply it power. Then you have little, what are these called? Pins, right? They allow you to, you can break these off and place them individually into the breadboard so that you can connect the female wires. Like you have a female wire, just connect it like that. Or is it the other way? Sorry. Basically whatever way you want, but it allows you to connect, so it's like a dual-sided male pin, and it has some other applications as well. Next, we have random various wires. So I'm not going to go over every single wire because they're all the exact same, but this just allows you to plug two ends of a circuit into each other, so and connect areas of a breadboard. So you can connect it here, and then just take the other end of the wire and just plug it in here, and voila, you have an electrical connection between the 2 points thanks to the wire. And there's a bunch of them of varying lengths. So this is a slightly longer one, and there are even longer wires. Wait, let me see if I can pull this out without. Yeah, look, this wire is extra long. So that allows you to connect over a greater distance. Here we have a little module for you to connect to your Arduino, and it has a microcontroller built in. And what this allows you to do is it allows you to plug in motors. So this is a stepper motor. It's quite strong and powerful. Look at that, you can see stepper motor if you can read that, 5-volt DC. And the wire for this plugs into this, and this you can connect to your Arduino to control a motor, which can allow you to do some really interesting physical stuff. Next, we also have the remote. The remote allows you to control things, well, remotely. And right now it's in the packaging because I haven't used it actually, but this is what the IR receiver that was shown earlier is for. Next, we have a bag of LEDs. This bag of LEDs is all different colors, and obviously according to V equals IR, then you can light up these LEDs as long as the current passes through them. We've got a bunch of different stuff here. So let me open this up. So obviously the biggest thing we have is a potentiometer, which allows you to change the resistance. It's like, well, not change the yeah, sort of do that. Because if you want to see how this works, look in a physics textbook, but essentially there's a slider inside and a piece of like a strip of metal or a strip of resistant metal, and when you slide this, it slowly moves a little piece across, and the farther to a certain direction you go, the more resistance there is. I'm not sure, you'll need to look at a diagram to understand what I'm trying to say. Then we've got passive and active buzzers. So these buzzers, these little buzzers, make noise actually when you connect them to electricity. Next you have some button caps, which I don't think you need me to explain to you what a button cap is. You just put it on a button. And you have the base for the button, so you can connect them to your circuit. Next, you have this little box, which you can place whatever you want in, but what I've placed inside it is, let's see if I can get it open first. Yeah, is a LED that you can make display any color. It's an RGB LED if you can read the, is it focusing? RGB. Trying to see if this is focusing or not. RGB LED. and you have a DHT11 temperature and humidity sensor. So what the sensor allows you to do is it allows you to detect temperature and humidity, which is really useful for you know, projects involving plants or the weather. And you can just close that little box again and put it back. So thank you so much for watching this little introduction. Now I'll show you some of the devices being used. And today I'm going to be showing a few different things you can do with some of the components in this kit, like these buzzers, this potentiometer, this LED, etc. So first step, as in Arduino, you can you can choose which ports output electricity. So I'm going to choose port 8 for this, port 8. Then you want to plug it into whichever slot you want. And I'm going to connect an LED, and this LED has, is this focused? I hope it is. This LED has 2 points, a longer one and a shorter one. So the longer one is the positive, the shorter one is negative. So since this is the output, aka positive, I'm gonna plug the longer bit into this little area. Next, like I told you, if an LED has too high of a voltage or a current flowing through it, it's going to get fried. So we need to add a resistor. So this is a 220 ohm resistor, and I'm going to connect this over here. And if you can see what I'm doing, you'll see that everything so this goes vertically upwards towards the LED. Then the LED takes the current up, moves it to the second bit, and moves it downwards where it connects to the resistor. Next, we need to connect the resistor to the negative terminal. So we're going to look at the line it's in, connect a wire to the same line, because remember, current flows vertically, not horizontally, and you want to connect it to ground. So this is a ground circuit. And look at this, it's already working, as you can see. Now I'm going to upload a little piece of code. And what this piece of code does is it makes the power output switch on and off every half second, or every 1 second it's going to switch on and off, and that allows this LED to blink. Now what I'm going to do is I'm going to take a couple more wires, so I can grab some more wires. I'm going to show you what happens when you connect multiple LEDs in parallel. So let me unplug this real quick. Let me keep the same resistance, but what I'm going to do is I'm going to connect a couple of LEDs instead. So this is just a little circuit. Connect another LED, this time a blue one, if you can see that. Can you see that? I'm concerned this isn't focusing. Okay, there you go. So we're gonna connect a blue LED. Let me see if I can get this right. And now we're going to connect the same red cable. And you'll notice that although the LEDs are working, they're a bit dimmer, aren't they, compared to before? Now I'm gonna do something else. I'm gonna connect a third LED over here. And I'm gonna connect this also to the blue LED. Sorry if the circuit's getting a bit messy, but it's just the way things are. And it looks pretty cool, to be honest. Now look what happens if I connect this thing into the output. The LEDs don't switch on at all. Now, why is that when I keep adding LEDs, the power turns dimmer and dimmer? Well, the reason is that as there are more LEDs, do you guys know how LEDs emit light? Basically, they have a small resistor in them, And when a current passes through them, a little bit of light is converted to a little bit of, what do you say? Electricity is converted to light. Now, when you have three LEDs in series, then the combined what do you say? The combined resistance of the LEDs is reducing the current so much that the current isn't sufficient to switch on the LEDs. It reduces it. So look, as I plug it in, it goes back to normal. Now, I'm just going to show a demonstration with another object. So for this one, I'm going to get rid of the resistor, and we're not going to do LEDs for this. Actually, you know what, I'll display the LED one first. So here we have our potentiometer, and we're going to connect it into the circuit. Now, this is the positive, this is the negative, and this is the output of the potentiometer, if you can see that. So these are like the terminals where the current flows, and in the middle is the output terminal for when you change the resistance. So I'm going to plug this in like this, like that. Connect this red wire to the same one where it's there. And I'm going to connect a wire from the middle of the potentiometer. It's a bit finicky because they're small, but yeah. And you'll see it's quite dim. It's quite a dim light, yeah? So let me change the code a little bit so that I can show you this better. Where is it? Yeah. So I'm just going to, yeah. That should... Okay, so look, now the LED is permanently on. I stopped it from blinking. Now, I'm going to show you what happens when you change the voltage. So look at that. Do you see that happening? Let me see if I can bring it a bit closer to the camera. Do you see what's occurring? As I decrease the resistance, the LED gets brighter. So here's the maximum resistance, pretty dim, and here's with very low resistance, very bright. Now, if the LED doesn't have enough resistance, it's actually going to get damaged. So make sure not to give it too high of, like, too little resistance for too long. But this allows you to change the brightness of an LED, and that's actually quite cool, isn't it? Now I'm going to show you something else. Let's remove this potentiometer. Let's remove this wire and this LED, and I'll showcase what a buzzer does now. So let me just get a little bit of code. And here we have our passive buzzer and active buzzer. So I'm going to show you the difference between these two. So as you can see, this one has a little epoxy resin and this one has nothing underneath. So I guess that's how you just differentiate between these two. Can you see that? They're fairly similar in all other aspects, except the active one has a little name right there, THDZ. Okay, so what I'm gonna do is I'm gonna connect this buzzer and see what happens. So you have a little buzzer. So first we're gonna start with the passive one. Passive one, you just plug it in and you change the current. Now let's see what happens. Strange. Why is it not working? Something up. Upload. Did I potentially plug it into the wrong section? Never mind. Oh, okay, I figured out my mistake. I'm not sure if you can hear that, but it's making a very faint ticking sound. So when current runs through this passive buzzer, it makes a little click. It might be very faint on your end. I hope you guys can hear that. And what I've done is I've made the the voltage switch on and off every 1 second. So that keeps ticking and repeating. So that's enough of the passive buzzer. Let's try the active buzzer. Active buzzer is a bit louder and a bit more emergency-like. So you just heard a little bit, but let me connect it. Okay, I'm gonna remove that before I wake up the whole house, but that's basically what these buzzers do. They make little noises, and these are useful for little alerts. In case something goes wrong in your circuit, you can program it where these buzzers will switch on, or you can just, I don't know, make it to give your friends a little shock when they wonder, like, oh, what's that? What's that? Why is it buzzing so loudly? So those are the basic components. The sensors, etc., and the motors require a bit more programming, so I'm not going to show them in this video, but I hope you guys got a basic idea of what's possible with this kit. And thank you so much for watching week 1 of 365 days of engineering and this little introduction to this starter Arduino kit. And thank you so much for watching. Remember, if you like the video, then please remember to like, and if you are interested in more videos like this, showing off stuff like this, then remember to subscribe because I do weekly uploads. Thank you so much for watching, guys. Bye.